As the heart of high-tech corporations, Silicon Valley's population is growing with new residents, commuters, and students. While from an economic point of view, expansion in these companies to accommodate extra openings like Apple's new campus is beneficial, it creates problems in other areas like traffic. To help better depict the problem at hand, we present a familiar residential area around the schools Monte Vista, Kennedy, and Lincoln as a microcosm for the traffic problem at Silicon Valley. Because this residential area is closed off from the Silicon Valley with only one exit, the Bub and McClellan Road, transportation is made extremely inefficient. Everyone takes the same road out of the residential area, and thus the commutes to and from workplaces are throttled, and it often takes much longer than it should to simply move to a highway. The same thing is happening with large companies in the Silicon Valley. According to a recent study by Todd Littman, more than half of the Silicon Valley population resides in just 6 of the 39 cities, creating these closed-off residential zones we were talking about previously. Large tech companies like Google, Cisco, Intel surround this residential zone bubble, requiring all residents to use the same exit routes for these residential zones, thus creating the traffic jam congestion throttling that we frequently observe. In fact, if we look at this Google Maps data for the 8:15 morning commute, we see that the traffic is highly localized in the red region, representing those few exits. The solution is simple, right? Build more highways and roads? While this may potentially solve, it is not a permanent solution. According to a 1997 study, the medium-term elasticity of highway traffic with respect to California state highway capacity was measured to be 0.6 through 0.7 at the county level, according to a study by Hansen and Huang. In other words, this means that building more highways is only a temporary solution, as 60 to 90% of increased road capacity is filled with new traffic within 5 years. The first part of the plan lies in creating a denser network of public transportation systems in the hotspot residential area indicated in the before-mentioned 6 cities of high population. The current public transportation system Caltrain only provides one route out of this residential area, which makes it an inefficient solution to this problem. This pushes people to use freeways and highways instead for the local trips, thus creating this traffic congestion that we frequently see in the Google Maps data. In order to fix this, one step in our plan is to interpolate more nodes of public transportation throughout this residential bubble. Providing funding to Caltrain or creating other public transportation venues will allow more access points throughout this residential bubble, instead of just a single route, upping the appeal of public transportation and keeping the freeways and roads less congested. Increasing the options in which commuters can exit out of this residential zone will thin out traffic, thus reducing congestion in the Silicon Valley. The second part of this plan is to improve operations of the Silicon Valley facilities that we already have at hand. Instead of directing money into programs like timeshares, carpooling, and rideshares, in which citizens will not fully commit towards, thus wasting money, we suggest a strategy that will bring about positive change while A, using the current facilities at hand, and B, require minimal funding. To enhance the current road systems of Silicon Valley, the second part of our plan is to propose a mixed scheme of one-way roads and selective lanes, reserved specifically for commuting that have special regulations during peak traffic hours. The way this plan works is multifold. While increasing the efficiency of our current transportation system by giving us the ability to direct traffic, it will also direct people towards the previous plan at hand, public transportation. In order to implement this, computer simulations can be ran to figure out which one of our current highways and streets can be converted to one-way streets. Research computer simulations of different networks and combinations of streets will allow the optimization of traffic efficiency. By also using selective lanes reserved specifically for commuting with special regulations during traffic hours, we will be able to cost-effectively manipulate outgoing commute traffic while fully utilizing our current resources, thus saving money. The end result will reduce the tangled network of commuters that are trying to move out of the residential bubble, thus streamlining the commute process in order to reduce traffic congestion in the Silicon Valley. But of course, we want to have a system that sets a standard for the future. The last part of our plan is to implement a long-term transportation system that will benefit us in the future. As our last part, we propose a system of bike highways in order to set the roadwork for a greener future, perhaps where people can commute through. thus increasing the general health standards for the citizens in the Silicon Valley while improving traffic. We stand by our original methodologies for interpolating the residential bubble with these bike highways that will increase the amount of options citizens will have to commute to work. Similar cities and countries such as Minnesota, Vancouver, Denmark, and the Netherlands have found success in these freeways. In fact, Germany has connected 10 western cities and 4 universities throughout a network of bike freeways, and the study has found out that this network has taken over 5,000 vehicles off the roads every day. As a result, this bike highway will surely improve the traffic congestion in the Silicon Valley. In conclusion, our plan to improve the current traffic situation can be split into 3 different steps, each broken into varying levels of financial feasibility and practicality. A step towards a greener future and a less congested Silicon Valley.